Hello students, here we are going to learn about switch-based network. So connection among processors and memory modules are made using the simple switch. So first of all, we have discussed some of the switches. So crossbar, single stage and multi-stage. So first crossbar. So crossbar network represent the other extreme to the limited single bus network. So simultaneously connection to all among its input and all its outputs. So the crossbar contains the switching element IC at the intersection of any two line extended horizontally or vertically inside the switch. So here in this diagram, the crossbar element, so it is 8 bar crossbar network is there. So here is the two kind of structure is there. One consider as a one diagonal structure. So the different part of switch is there, and all other switches are considered with another. So this is a square block like switch is known as a straight switching setting. So this is a straight switch, and these are the diagonal. The shape is like that. This line of sweep, as I am considered over here in large. So it is known as a diagonal switch. So in this case, general we have to connect the 8x8 bar network with this two kind of switch. One is a straight switch and one is the diagonal switch. So in this general, from the n cross n crossbar, the network complexity measure in terms of switching or number of switching point. So the crossbar is a non-blocking network that allows a multiple input and output connection pattern or permutation block to be achieved simultaneously, and the message delay to transverse from particular input to output is always constant, and consider of the regardless of which input and output are communicating. Clear? So in the next, single stage network. So in this single stage network, switching elements exist between the input and the output of the network. So the simplet switching element that can be used 2x2 switching element. I'm just considering somewhat example over here. So one is a straight, so direct straight line is connected between input and output. So this is a straight. Second is the exchange. So in the what is exchange? So first is going to the second of, and second of input to the first of output. So this is an example of the straight. This is an example of the exchange. So that's why I'm writing E over here. Third one is upper broadcast. So in this case, upper data is there, they will simultaneously pass to the lower also. This is known as a upper broadcast, and same as a lower broadcast. So the dominant or down signal will pass in the upper stage. So this is a lower broadcast. So to establish communication between a given input source or given input to output or given source to the destination, data has to be circulated a number of times around the particular network. So in the multi-stage, the multi-stage means MIN, multi-stage interconnection networks were introduced as a means to improve some of the limitation of the previous case or single systems. So the most undesirable single bus limitations that mean is set to improve the availability of only one single path between the processors connect to the multiple line. So the memory modules also, such as MIN, provide a number of simultaneous paths between the processor and the memory module using that multi-stage switch. So the particular the diagram of the multi-stage is like that. The switches is connected the one network to the another network. So this is a one stage up to the X minus stage. So this is a multi-stage interconnection network diagram is there. So here the main consists of number of stages of each consists set of 2 cross 2 element. So stage are connected to each other using a interstage connections. So what is the interstage connection? IAC, interstage connection 1 to x means x minus 1, 1 minus, consider as a 0. Clear? And so this pattern may follow any of the routing functions such as a shuffle or any kind of exchanging, any kind of queue function is there, or so any kind of many requesting is there, can be performed in this MIN. Clear? So in this case, the MIN also exists, n cross n MIN network also. Then the number of bits in any destination addresses in the particular network is provided. So each bit in the destination address can be used to route the message through one stage to the another stage, or like a one stage to the n stage. So this kind of scenario is provided by and multi-stage. So next most important parameter, routing node functions. So several functions are available. So decoding of the packet header. So many kind of information is available in this packet header information. It always providing some kind of addressing mechanism, some kind of IP mechanism, MAC, or something message or packet data format. So all this process is defined by the routing node. Set up a switch fabric. So it is provided that the which kind of switch fabric is required to connection with the particular node, input node to the output node. Synchronization between the two data by some of delays there. So provided some access delay to provide synchronizations between them. Multiplexing. The last one is contention resolution. So what is the contention resolutions? So this particularly provide the or deciding which kind of or which device gain access to a resources. So select resources first, and when more than one wants to use it. So many of network node is there at a time, only one or two path is there to which the particular require the first uses of the particular path. Clear? Or particular gain access to these resources. So when more than one wants to use it at the same time, the particular is provided. So this is known as a contention resolution. Deflection routing. So deflection routing is one kind of rerouting of internet protocol networks packet to eliminate heavy data traffic at the root interface and avoid packet buffering when the network packet are transmitted with the same root connections. So many kind of scenarios happen when the single link is there or multiple data is transmitted to the single root. Clear? Deflection routing is used in modern networking to reduce the system and infrastructure expenses. So using then you can use the less number of devices and your network become more complex. So at that time less number of devices is there. So this network become less complex compared to the previous case. Clear? So deflection routing during the node receive the autonomous network data packets which are forwarded without buffering to the nearest destinations point via the shortest path available is there. So using some kind of routing mechanism or routing algorithm is used case of the flooding, or the shortest path algorithm is there. So using this algorithm, the nearby destination is selected for the transmission of the particular data without considering as a buffering for the particular packet. So this process reduces the traffic and the network complexity. So deflection routing functions optimally when implemented with the optical networks. So in this case of switch-based network also. So deflection routing has a disadvantage. Some of like that include the network bandwidth is used inefficiently because each and every case the without buffering data is sent to the nearby destinations. Packet are received out of order because they are not in the buffer stage. So they are not any kind of acknowledgement is there considered for the particular data is received in the particular path or particular number of packet has received simultaneously. And third thing is QoS, means the quality of service implemented is a problematic because there are some of the scenarios retransmission and the failed packet and the lost packet is there. Next is a feed forward and the feedback delay lines. So in the OPS network, the packet contention is a critical factor. I'm also discussed these things in the contention route. So which occurs at the switching node whenever two or more packet try to leave the switch fabric on the same output port. So many number of port are available in the switching network or routing network. So they uses the same port for the output of the particular devices on the same wavelength at the same time. So this is one scenario. So optical buffering approach based on the fiber delay line is the most cost effective as well as the widely used in solutions for the contention resolution. So fiber delay line or fiber delay line length selection scheme provide better performance. The throughput and the delay performance of the switch under various FDL length selection scheme is compared, or based on this scenario, the particular network or capacity of the network or input output scenario is considered. So a series of computers simulations are performed in order to obtain the performance parameter of the switch.